So something that happens in Unity a lot is that you get a big project, you get a bunch of classes, you get a bunch of components, and then a month passes, a few weeks passes, and you look back at it again, and you kind of lose where you left off, or like you're not sure, like, what was I doing here? What was my intention here? So I found a way to like leave yourself notes within Unity, kind of like a built-in way to do it. So I want to show you guys how I handle that, because this is a pattern that I've used in all my projects as soon as I figured it out. So it's we're going to use a little bit of inheritance, and then just a little bit of scripting, and a little bit of attributes. So down here in the scripts, I'm going to create a new script. It's going to be like a base class that everything in Unity is going to inherit from. And so you can name it whatever you want, but I'm going to run this pun dry, so it's going to be called a rich mono behavior. So every object in Unity inherits from mono behavior. So mono behavior means it's a component. It means it exists on a game object. So the words component and mono behavior are kind of synonymous or interchangeable. So camera is a component, audio listener is a component. These are all mono behaviors. Everything that's in here is a mono behavior. So what I want to do is leave myself a note. So what I'm going to do is create a public, or it's going to be protected. Now, you know what, we'll do the public. I won't get too hung up on that. It's going to be a string, and it's going to be called developer description. All right, so this is real simple, and we won't see anything yet. So let's change the player to inherit from that. So instead of so this is the player controller. Instead of inheriting from mono behavior, the rich mono behavior already inherits from mono behavior, so we're just going to interrupt it a little bit. So player controller, I'm just going to stick the word rich here. And so rich mono behavior, why didn't you like that? Rich mono behavior, public mono behavior. Oh, right, because British. All right. Yeah, I'll fix it. So, right, behavior. Excellent. So it's good practice. Always have your class name and the title of your script, or the name of the script, they got to be the same. Things won't break, but like sometimes you'll miss features, or like sometimes Unity has trouble with that. So it's always good practice. Make sure they match. Behavior. Good catch. Thanks, Albert. Or thanks, Jared. Appreciate it. All right. So all I had to do is prefix my class, and it's interrupting it. So player controller is still a mono behavior. It just got this little extra string here. So let's do. I'm just going to make a header real quick. Header player controller. So anything in brackets is an attribute, and we call attributes they're a form of meta programming. Super fancy. So Unity doesn't, or your game doesn't do anything with these. These are purely for you. So they're programmer. They don't get compiled, or maybe they do, but they don't end up in the game. They're just visual. So now if I look at my player, here's the player controller. So here's that header that I made down here. So it says header player controller. This is what you see now. And then notice it has the developer description. So even though developer description is not in my player controller, it's in the rich mono behavior. And I can't read all of it. It gets cut off. I only get to see up to the corner part of it. So I'm going to use another attribute, and it's going to be text area. And I compiled a whole list of all these attributes, and I've got this fun talk that I do where I show you all of them, and there's some really cool stuff you can do with them. But these are the only two we really have to worry about for this right now. So I just added a text area onto the string, which means when it recompiles, there we go. Now I got a whole block. So I can keep going, and notice there's even a scroll bar when it gets too big. So now I can kind of leave myself notes, right? So I can tell myself, like, you know, this is the player. This is the player. You know, I can do all kinds of things here, but So in my projects, the big ones are so mono behaviors, UI elements, and scriptable objects. I've got a rich mono behavior, a rich scriptable object, and a rich UI element, and they all do some other things that I think are really handy. But for the basis, this is the goal of it. Is now I can leave myself notes. So that's something I'm going to do in all of these. Maybe not right now, but just kind of as I go along. If I see that this isn't here, I'm just going to add that. So that way, I can kind of document my code as I go along. Does that make sense? Any questions on this bit? Cool. So we just created a new class, called it rich model behavior, or anything you want to call it. And now anytime I create an object, if I want it to have that extra functionality, I just have it inherit from rich model behavior instead of regular model behavior. So nothing else changes. It just gets that little extra bit. All right, so unrelated to that, we're going to pivot on to collisions. So we've done collisions a little bit. As like you can see the box collider here, we've kind of started it. I think we got to the point where we could destroy enemies. Let me try that again. Yep. All right. So collisions, right? So let's just test this out really quick. Let me bring in my enemy ship, move him up here, and if I shoot him, he should blow up, which he does. Excellent. Cool. So collisions do in fact work, but we have a small bug. I'll point it out to you here. So the player, he also has a collider. So I'm gonna enable it. So now it's a trigger. So now the player's collider is enabled, and now I'm gonna shoot. Can anybody tell me what happened? What the bug is? Yeah, Jared, you were quicker. Sorry. What's up? Yeah, exactly. The bullet spawned exactly where the player is. And so immediately the collision happened, and we can go back into the script and we can see it. I think it's on the projectile. Yeah, so the projectile. So as soon as it spawned, I destroyed it. So I just want to kind of prove that. So if you ever don't know, oh, what happened? I have a bug. So here's how you fix that. Or here's how you can find out some more information. Debug. You can use debug.log, and then C# is really cool. You can print anything in C#. Like you don't have to convert it, or you don't have to like do any song and dance. Like C#'s really smart, so I can just stick other in there, and it'll print it. But I'm gonna do other.name. That's a little bit smarter. So every game object has a name. Just this bit up here. So I just want to, when it gets destroyed, I want to print its name. And so there, the player, so I have a bug. The player is being deleted when I fire the missile. So that's the problem we're going to solve with collisions right now. So I'm going to comment this out because we don't need that. And then, all right, so there's 3 ways I can think of to solve this problem. I'll show you 2 of the ways and then give you an idea of the third way. The third way, we'll use layers, and those are kind of complicated. But we're going to use this function here. It uses onTriggerEnter, and it's blue. Visual Studio is telling us that this is a built-in Unity function that Unity calls. So like update, start, you don't ever call start. You don't ever call update. Unity calls those automatically. So that's why onTriggerEnter is blue. Because we don't know, that's just an automatic, sometimes I'll use the word callback, and that's what I'm referring to is the blue ones. So inside here, we're gonna add some logic to not blow up the player, or not blow up the owner, because the same thing will happen. If an enemy shoots a bullet, it'll do the exact same thing. It'll blow up the enemy instead of traversing it. So we can't just say, oh, don't destroy the player. We have to say, don't destroy the object that shot the bullet. Does that make sense? Okay. So, right, so when we instantiate the bullet, we have to tell the bullet who's owning it. So that way the bullet can can check and say, can use that in its comparison. So in our let me get these right next to each other. Player controllers. Okay. So in the projectile, it needs an owner. So let's start with the string. So I'll show you the quote unquote worst way to do it, or like the not best way to do it. There's nothing wrong with this. It'll work great in small projects, but strings aren't ideal for comparisons, and I'll show you why. So this is the owner. So public means anybody can set it. String means it's a bunch of letters and numbers and characters, like a word, and then its name is owner. And so down here, all I'm going to say is if, so it's a string. So I'm going to say if other, I'm using other because it's right. Unity knows other is the other collider that we've hit. So so the other collider that's been hit, I want to access its game object, and then I want its name. And then I'm going to compare that to owner. And then return. Okay, so from the top, other is the other collider we've hit. Every object has a reference to its game object, and I want its name. So say I hit say the bullet hits the player, it's going to look at its collider. So this is other, and this is going to say other.gameObject, and that's this whole thing. And then it wants its name, which is player. So other gameObject.name, comparing it to the player, and then we're going to return. So return just means stop executing the function, and this is a void function, which means it doesn't return anything. So we don't need anything else. It can just return, and it just says stop performing the function, and then go back to what you were doing before. So if the other object's name is the same as our owner, don't do this. Does that make sense? Okay. So now what we have to do is tell the projectile who the owner is. So we already instantiate. That's the fancy word for create an object. So we do this when we shoot. Whenever we shoot, we instantiate a projectile prefab. So we have a blueprint of what we need to make. We're going to clone it. We're going to put it at this position with this rotation, and this is just fancy for no rotation, which that's a bug, and I'll fix that. But so instantiate also does something extra. So instantiate also returns, when it creates an object, it returns a reference to that object. Projectile geo. So instantiate will create the projectile prefab. It'll clone it, and then it'll say, here's the reference, the thing that I just made. I'm going to put that reference in here, and it's going to create a game object. So that's the type and then the name. And we can use the equals because that's returning something. So when the game object gets when the projectile gets created, I'll run it real quick. Hopefully there's no bugs. So I'll turn this off. Shoot pause. All right. So I shot the bullet. I paused it really quickly. And then so here's so it says clone because it's been instantiated. So it's just letting you know it's a clone of something. So so right now, game object projectile geo has this game object right here, but we need more than that. We need its component, the projectile controller. So before, when we needed components, we made it a public, and then we just dragged it in. But that won't work here because this is during runtime, and we can't click and drag when the game's already running, if that makes sense. So we have to do this pragmatically, or we have to do it at runtime. So right now we have a reference to that game object. We have this, but we need the controller on it. So we're going to do something very similar. What do I want? I want the projectile controller. So I'm going to write projectile controller. And now I need to give it a name. I'm really creative with my names. It's the exact same thing, just with a lowercase. But this is a reference, and so we have to fill it. So we're going to use equals. And then where is this located? This object is on the projectile. Nope, it's on the game object. And we're going to use this function called getComponent. So this getComponent is going to look a little funny. What's up, Jared? What's up? Yeah. You can. I'm not finished with it. It's underlined. There's more I have to do to it. But you're absolutely right. So so we have to tell it what component we want. We want the player controller. So that goes inside the angle brackets. So you probably haven't seen the angle brackets before. It's because getComponent is what's called a generic function, which means it works with any type you want. So notice that whenever we create a type, we don't have to hand code our way of getting it. Unity's already got a super awesome way of getting anything you create. You just have to use this pattern. It's in angle brackets because it's a type. I can go into way more detail than that if you'd like, but for the most part, that's all you need to know, is that when you use getComponent, you need the angle brackets and you have to give it a type, and there's no other arguments. So getComponent, it will look, so we use this is the game object, so we're calling getComponent on that object, and we're getting it of this type. So getComponent will look, it'll say transform, that doesn't match, projectile controller, that matches, so now we have a reference to the projectile controller. Fill or init projectile. So we're going to do two things. One is that we haven't really done this yet, but I want there's going to be a player shooting a bullet and there's going to be an enemy shooting the bullet. And for the sake of game design, I want the player's bullets to move really fast, but I want the enemy bullets to move really slow. And a lot of games do this. The player has a big edge. So depending on who shoots this bullet, I want there to be a different speed. And then I also need to set the owner. So there's two things I need to set. So I'll set the speed. So I've got a reference to it. So this projectile controller is this guy over here. I can stop this now. Oop. Yeah, so I've got the projectile controller. So I want to change its move speed. So this is the player. So I'm going to say public. It's going to be a float. Projectile move speed. I think it was 150. So down here, so the player moves its right. So projectile controller dot move speed, yeah, is equal to projectile move speed. Oh, projectile move speed. Sweet. And then we also want to set its owner. Okay, now its owner is if you forget what it is, Visual Studio is cool, you can just hover over it, and it tells me that it's a string. So I need to fill it with a string object, or element. So I'm going to do its name. That makes sense. Oh, wait. Yeah, so it checks the name, and it compares it to its owner, so that's exactly what I want to put in here. Put in this, gameObject.name. So this is it's a pointer, so like I could have 10 players, so which player does it pick? It picks this one. It picks the one that it's attached to. And then the game object, and then the name. So that's exactly the same thing. So here's the player controller. This .gameObject is this whole thing, and then my name is up here. So let's see if this works. So I'm setting the move speed, I'm setting the owner. Yeah, let's check this out, let's see if this works. So I shoot the bullet, yep, and it blows up the enemy, but it doesn't blow up myself. And I guess I turn that off. Yeah, thank you very much, thank you very much, thank you very much. Hey, well, thanks for stopping by, Jared, thanks for coming. Projectile controller. So let me just do this real quick. So I always want to know who I hit. So I'm going to debug log the name. Let's run it again. So I should see my name and then an enemy. Yeah, so it hit me. I can double click on it and brings me right. So how cool is C#, right? Or Unity, like here's my debug. I can just double click it and there's the exact line of code that called it. That's pretty cool. So yeah, so this function was called twice. It hit the player and it ignored it, and then it hit the enemy and it destroyed itself. So that's neat. That's exactly the behavior we want. I like this. However, strings are inherently bad for comparing. They're expensive, right? So every time you do this thing with the string, it copies this string and it copies that string. So it's not terrible, but we're game developers and we're trying to crank out as much as we can during every cycle. So this will ship and this will do fine. But if we're going to make something bigger, we might want to really squeeze and narrow out as much performance as we can. So I'm going to show you something a little bit easier. So when the computer compares strings, it's going to look at I'll just write it down real quick. So it's going to look at every single letter. So is this the same as this? 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 So it's a lot of checks. It has to check, depending on how big the name is, it has to check that many times, and that's a lot of wasted resources. So it's petty, but we can do better. Does anybody have an idea of how we can do better? What's up, Michael? Character? Yeah, that would reduce it down to a single check. And then we could say, player is P, enemy is E. We could do that, and that is a good way to really narrow it down. But we might run out of characters, or there might be duplicate characters. Integer's good. Yes, we can use a reference. Did you have an idea, Keon? Tagging? Yeah, tag is really good. So I'm going to do tags first, and I'm going to do references. Because tags are really useful. Some you don't really have to use them, but I think they're great, and they really work well with Unity. So every game object has a tag, or can have a tag. Right now it's untagged. The enemy ship is untagged. So every object has a tag, and these can be used for a lot of different things. But let's do this once for comparing, just so you can see how to use tags, and then we'll do the reference one. So tags. So let's create a tag. So right now I've got some built-in tags. Every game comes with these, I believe. So I'm going to tag my player as player. Ooh. Now the enemy ship, it doesn't have a tag yet, so I'm going to hit add tag. And I'm going to hit the plus button. I'm going to just name it enemy ship. Okay, so I've added the tag, but I haven't updated that tag. So I go back to enemy ship. You have to go back. Now I go back to untag, and now enemy ship is there, and I've tagged it. But that only changed this. I need to do that on the prefab. So enemy ship down here in the project, tag enemy ship. Yeah, so that way, yeah, it's all updated now. So if I delete this, bring this in, move it up there, enemy ship, perfect. All right. So we've got a tag. So checking the name is more for your developer. Like your game probably shouldn't check for names very much, because that's not a pragmatic thing. That's more of a developer. That's what you are reading. So that's not what the computer should read. So let's do the tag. So on the player controller, instead of putting in our name, let's put in our tag. So I think we can just do tag. So this is good for two ways. One, if you're a really fast game developer and you're typing away, well, just like this, player 1 in parentheses. So this is different than this. So if you clone something, now its name is changed, and that could be undefined behavior if you don't know the name is changing. So what I'm trying to say is don't count on the name. That can change, and you can't count on that. So the tag is great because that's a little bit, it doesn't change as easy, and there's only so many to choose from, and it's selected. So there's no typos, there's no typos. There's only so many to choose from. So this is and under the hood, they're integers. They're not characters. Does that make sense? So this is tag 0 is untagged, tagged 1 is respawn, tag 2 is finish. They're kind of like enumerated data types. So that's a lot cheaper than strings. So this dot tag, right? So we're giving the owner a tag, and then the projectile, we're not checking against its name anymore. We're going to use a new function, and this is a lot cheaper to use. It's going to be called other.compare tag. All right, so the only thing we changed is that we're using the tag instead. So tag, compare tag. So you can do, how did I do it before? So you can do other.tag is equal to owner, but that equals sign is expensive. That equal sign is a piecewise, first character is the same as the first character, second character is the same as the second character. That's expensive. So we can use this compare instead. It's a little bit more streamlined, and it's a little bit quicker. So let's try this. I think that's going to work. Let's try it out. Run it. Fire. Yep. So we have the exact same behavior. It's hitting the player, but ignoring it, hitting the ship, detecting that it's bad, and kills it. And then I fire 2 bullets. That's what the second one is. So this works too. And on a small scale, the two things are interchangeable. There's no real reason to do one over the other. But as, say you've got 1,000 bullets going on at once, this is a lot cheaper than the string checking. Any questions so far? What's up? So strings, it's not a whole lot of memory, or like as far as space goes. It's 8 bytes per letter, so it's not a whole lot. What's a player's 6 characters, so like it's less than 100 bytes. It's not a big deal, but it's the number of cycles it has to check, and then it has to iterate. So it's got a counter, and then it iterates through each one. So it's not really a matter of space. It's more a matter of time. So Albert, you said the reference. Yes. So that is a really good way to do it, because a reference is a number, and so it's not a string. So let's do it that way instead. So inside the the projectile controller, instead of a string being the owner, let's make it a game object. And then this is broken, so I'll come back to this. So owner is game object, so instead of saying this.tag, we can just give it this game object. Yeah, so we've set the owner. And then down here, we can go back to using the equality operator. If our game object is equal to owner. So it's really easy for C# to compare references. C# is very, everything in C# is a pointer for the most part, or is a reference. They don't have pointers. So it's super easy to check that. It's just, that's a numerical comparison instead of string comparison. So that's really easy. So I think that's all I had to do. I changed owner to a game object, made the comparison, and then passed in this.game object. So I think that's enough to work also. Let it compile. Run it. Yeah, exact same behavior. So teeny little differences. And again, comparing by strings isn't going to make your game blow up. But every little change, it's like going on a diet. You just eat this and not that. You don't change your whole diet all at once, but maybe eat an apple instead of a bag of chips. So to this extent, instead of comparing strings, maybe compare references. Any questions so far? What's up? Yeah.
I wasn't sure if the game object instantiate reference was a pointer or not, so I just looked it up and it actually is a pointer.
Yeah.
So you can't do any pointer arithmetic to it, but it's like
correct.
C++ pointers.
Yes. Yeah. So C#. The semantics are a little bit different. C# doesn't have pointers. Yeah. It has references. Yeah. They're exactly the same thing, but you don't have to worry about dangling pointers. You don't have to worry about memory leaks. C# does all that stuff for you. So just to kind of play with that a little bit, integer, A, char, B, String C. What's another data or native data type? Yeah, longs. Floats. Yeah, vector3, or any of the vectors, any struct. So yeah, unsigned int. Yeah, signed and unsigned. We don't really use these a whole lot. I don't know. I think Unity even complains if you use it. Yeah, it doesn't even let you use. Oh, there we go. Uint. Yeah. So going off what you said about references. So these are primitive data types: integers, characters, even strings, unsigned integers, longs, floats. So from vector3 up, those are primitive data types. So those are all values. Vector3, value or reference? It is a value. So it's tricky because it's a class, but it's a struct. So I think if we hover over it, yeah, it's a struct, not a class. So structures are value types. Yeah. So every time you pass a vector3, it's a copy. So what I'm getting with this is this is kind of going deep. But anytime you pass, like, yeah, all right, I'll do it real quick. Private func int a number. Yeah, so this is void super whatever. So ignore my signature, it's gangster. This is just a function, it's just going to change this number to 10. Anything that you pass, like if this were float, or if this were long, or if this were vector3, anything that you pass into a function gets copied. So it's not a reference. A reference means it's like an address to your house. So like, if you pass a reference, you're just like, here's my address. It's just on a piece of paper. It's just my address. That's all you need to know to get to my house. But for all of these things, they're all getting copied. So anytime you pass a number 10 into a function, you've got another number 10 that exists inside here. So that's kind of outside the scope of what I was talking about, but it's a good thing to know the difference between a reference type and a value type. All right. So that does kind of lead into, I want to do one more step here. So you're probably thinking like, okay, every time I create or I instantiate a projectile, I have to do two things to it. I have to change its speed and I have to change its owner. That's a lot to remember. You know, it's only two things, but say we get going more, we get more in depth and we say direction or all the other things that can happen to projectiles. Say there's 10 things we have to pass on. The developer has to remember each of the 10 things that has to pass, and that sucks. That's tedious. There's a lot to forget. There's a lot to debug. So I'm going to create a function that initializes a projectile, and you only have to do one thing, and it's going to remind you of everything you need to do. So in the projectile, I'm going to create a new function that's going to be public because someone else outside of this class is going to access it. Void, it's just going to do something. It's not going to return anything. And it's just being called init. No. Init. Yes. All right. And I wanted to do the exact same thing. So anytime you create a projectile, it needs to have a speed. It needs to have an owner. So the owner is going to be a game object. And the speed is, I think it's a float. It's going to be, is it a float? Yeah, it's a float. Move speed. All right, so I'm going to say this dot owner is equal to owner. This dot move speed is equal to move speed. This looks a little tricky, but I have to say this dot owner because I have an owner up here. So I have to differentiate between, is it this owner? Or, yeah, so this is this one, and then this one up here is that one. Same thing down here. Move speed is this one, but this move speed is this one. Does that make sense? All right. So, and then if I had 10 more things that this needed to do first, I'd list them all here. But for right now, we're just doing the 2. So now, back in the player controller, every time I shoot a bullet, I don't want to have to remember all of these things I have to do. So I'm just going to call, what is it called? Projectile Controller .init. So now I just have to remember one thing. Anytime I create a projectile, I have to init it. What do I init? Well, I hover over it and it tells me I need to give it an owner and I need to give it a move speed. So this.gameObject and projectile move speed. Nope, projectile move speed. All right. So every time you shoot, you need to instantiate a bullet, and it needs some information on that bullet. So go ahead and cache the reference here so I can use it. I need to get the controller on it so I can change these values. So get the component controller from the game object. And then now I need to init it. So projectile.init, here's my owner, and here's my move speed. So that's doing exactly the same thing we were doing before, just in one function call instead of piecemealing it. And now I think it's a big surprise. It does exactly the same thing as before. So here's one more thing to show why this pattern is really cool, this initializer. Say I need to have a special effect, or I don't know, something extra, something special. So I can go something special, or game object special equals null. Okay, so this is a little advanced, but I've got a default argument right here. So these don't have a default argument, so these must be set. But this game object special, if you don't set that, it's just null. It's gonna take care of itself. So now, do I have to go back over here into the player controller and change anything? No, because it's got a default thing. So I don't have to go back to every single one that had that previous pattern and change it. If I want to, I can. I don't know what to do for this. I guess just this.gameObject again. And it's exactly the same. But if I don't include this, no compiler errors, nothing's broken. It handles it all internally. So that's kind of cool. Does anybody know, can anybody tell me what a constructor is in C++? Yeah. So every time you create an object, a constructor gets called. So C# has constructors, destructors, copy constructor, has all that stuff too. Except the way that Unity handles, so Unity under the hood is a C++ engine. Everything is done in C++. It is written in C++ all day. And it has a layer on top for C#. But notice up here in this class, we don't have any constructors or destructors. We have start and update. So that's because it's a mono behavior. So when Unity was written, it said, okay, when we do mono behaviors, no constructors, no destructors. Don't worry about those. You start, and we also have awake. That's almost exactly the same thing, awake. Yeah, so instead of using constructors and destructors, Unity says, okay, use initializers, use awake, and use start to do everything you need to do. So we use this pattern called init. So that's why this comes from, is we have to use instantiate to construct something. That's what we did over here. We didn't say, just as an example of when you could use one, back is equal to new vector 3. So vector is not a mono behavior, so vector has a constructor. So this kind of thing flies. New vector 3, that's okay to do because it's just a regular data type. I think if I do game object go is equal to new game object, that compiles. But what's going to happen? Let's try it out. Let's see I think Unity is going to complain. Maybe no complaints, nothing. That flies. All right, well, don't do this. This is bad form. Unity should be complaining, saying something about constructors right now. If I do this, wait, projectile. Yeah, there we go. No, wait. I'm just trying to get it to throw an error. That's all I'm trying to do. There we go. You were trying to create a mono behavior using the new keyword. This is not allowed. Mono behavior, yada, 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 yada. So, whoop. So mono behaviors don't use new. They use instantiate. That's the core of what I'm trying to get at. That's why we use instantiate to create new things. That's why we use a init instead of a constructor or a destructor. Does that make sense? Okay. So under the hood, Unity does some really weird things when you construct new objects, but things that it handles in C++. So we use instantiate to create new objects. And then if we need to, give them parameters or change them, then we use an initializer. All right. So that was a lot of theory of why we do it this way, but I wanted you to kind of understand the differences of why C++ is this way and why C#, or why when we use C# with Unity, we do it this way. All right, one final, I guess, pop quiz here. Move speed. When I pass in, is move speed passed by a reference or passed by value? What about game object? That owner, is that a reference to an owner, or is that a reference or a value? Mm-hmm. Yeah, exactly. So if I go down here and I say move speed equals 1,000 billion. So here I have a projectile move speed. It's up here, and I pass it in, and then I change it. I just changed it. I said move speed equals 2,000. But that does not change this guy's, because that's a pass by value, which is a copy. However, the game object is being passed in. So if I wanted to, I could say owner.name is equal to Jim Jeffries, and then I can do whatever I want. So this only affects this, but this affects owner wherever it is. Understand? Cool. All right. So what did we do today? We fixed the problem of the player shooting itself, of blowing itself up when it fired a bullet. We did it, I think, 3 ways. We did a string, we did a tag, and then we did a reference. So strings are cool, but if you want to tighten up a little bit, use tags. And if you want to really go the extra mile, I think references are the way to go. And then we also did that cool little, the developer description, get you a little comfortable using inheritance, and then also being able to leave yourself notes in your own scripts, and that's kind of cool. All right, I think that's a good place to end it.